Hey Monty, what happened to the costume?
Let's just say the mind was willing, but the flesh was weak. Also, they want you to sign this liability waiver.
Well, that's okay, because once we show these would-be heroes how to create advanced hero gear, the world's going to have plenty of new heroes to pick up the slack.
Consider recruitment open.
Shall we get to it?
Flip that switch. Are you ready to make the ultimate hero gear? Because that's what this invention is for.
For this build, you should feel free to use any one of the 3 pink input bits. I'm going to be using my favorite input bit, the accelerometer bit.
Combine the remaining bits: power, accelerometer, BLE, a wire to extend, and 2 green output bits, the round LED matrix and sound effects bit. This circuit will allow me to use my movements to trigger both a custom image or animation and a sound all at the same time. Let's attach it to the gauntlet. Flip the switch!
Don't forget about cable management.
Lastly, the hand mount on the round LED matrix.
Remember, nothing's going to happen until I send my fire code through the app. Code on!
Trying out a new catchphrase? Very good.
With the power of code, you'll be able to display sweet animations on your gauntlet. So many choices, but for this, I'll be summoning my Program Powers invention. I'll need to connect to my BLE bit. Nothing excites me more than a clean code canvas. Here, I'll start by dragging 2 send image blocks to my start block. Send image blocks send an image to my round LED matrix. Animations are created by showing one image and then replacing it with another, slightly different image. When we see this set of images very quickly, one right after another, our brains translate them into motion.
But what if it doesn't?
Have you been there this whole time?
Well,
Monty, if your brain isn't combining images, you need to see a doctor immediately.
I need to make a call.
Let's start with a simple animation made up of 2 images, or frames, like a heart beating. I'm going to go ahead and draw a heart in the first send image block. This will be the first frame of my animation. I can draw a smaller heart in the second frame. Once you have 2 frames, you can go ahead and start pumping out those GIFs. Timing blocks will control how long each frame will show on the matrix. To do this, I'll drag this wait 250 milliseconds block after each of my animations frame. If I want my animation to play a certain number of times, I can add a repeat 10 times block. I can also change the 10 to however many times I want the animation to repeat. I'm going to change it to 5. Let's run the code. Both frames play for 250 milliseconds. I can add as many frames as I want, but each additional frame should be followed by a wait block. A smaller number in my wait 250 milliseconds block speeds up my animation, and a larger number slows it down. I'll change it to 100 milliseconds. Here's what it looks like when I run my code. I might also want to use an input, like a button, to control when my animation plays. To do this, I can use a wait for input to be on block. Once it gets the signal, it continues on to the next code block. Let's say we want the heart animation to beat 5 times, and then shrink into nothingness. I can add a few more frames and wait blocks after the repeat 5 times block. If we want the button to work more than just once, we'll need to put all of our code inside of a do forever block. This way, once the animation has repeated 5 times, it will go back to the wait for input to be on block. Now when I run my code, I can press the button to see my animation. Anytime I want to see my animation, I can just press the button. With these animations, you'll be styling while saving the day.
Now it's time for you to come up with your own superhero identity and powers. In this video, we're going to introduce you to
the Frown Eraser, a superhero who works to eradicate sadness and misery by turning every frown upside down.
I started with the custom hero gear build and used an accelerometer as the input bit. But you can use any of the input bits in the kit if you'd like. I'll need to connect to my BLE bit. Remember, it's connected when the connection icon is green and the light on the BLE bit is also green. Sarah, this is where you take over with code.
Thanks, Monty. Now that I'm connected, I can drag an if-then-else block to my code canvas. Then, I'll put a signal from accelerometer is tilt left block into the if-then-else block and change tilt left to upside down. This code allows me to run code when the accelerometer is upside down and other different code when the accelerometer is right side up. I'll add 2 send image blocks to the if-then-else block. I'm going to show a smiley face on the round LED matrix when the accelerometer is upside down, so I'll draw it in the first send image block. Then, I want to show a crying face when the round LED matrix is right side up. I want this face to appear right side up when I have my arm flipped, so I'll draw my crying face upside down in the second send image block. I will now add a do forever block around all of my code so it keeps looping. Now, I'll run my code. When my gauntlet is right side up, I see the crying face. But when I flip my gauntlet over, I'll see the happy face. Now, I'll add a sound when the happy face appears. I can do this by adding a play sound block just below the send image block. Now, when the accelerometer is upside down, the send image and the play sound blocks will both run. Time to go turn some frowns upside down. For my invention, I use the power bit, button bit, BLE bit, wire bit, and round LED matrix bit. Connect to the BLE bit. Next, drag an if-then-else block to the start block in the code canvas. I'll then add an equals block to the if-then-else block and change the equals sign to a greater than sign. In this example, if the first value is larger than the second, the block answers true. However, if the first value is smaller than the second, it answers false. This green block is yet another type of block, called a math block. This particular block is a random block, which gives us a random number within a particular range. In this case, between 0 and 100. I'm going to drag another type of math block, a number block, to my code. Number blocks simply hold numbers, and mine is going to hold the number 50. Now I'll add 2 send scrolling text blocks inside the if-then-else block. I'll write yes in the first send scrolling text block and no in the second.
Run the code!
If my random number is greater than 50, I will see yes scroll across my round LED matrix. But if the random number is less than 50, I will see no. To trigger the fortune teller with the button, I'm going to need to add a little more code. First, I'm going to need to check to see whether the button's been pressed. I can use an if-then-else block and a signal from input is on block to do this. Now, if the signal's on or if the button's pressed, yes or no will randomly show up on the matrix. I can code what I want to show on the matrix when the button is not being pressed with a send image block. I'm going to draw a donut. If I leave the code as is, it will only check whether the button has been pressed one time. To keep checking if the button is pressed over and over again, I can use a do forever block. Now, when I run the code, the button triggers a random answer, yes or no, on the round LED matrix. I can alter the code just a bit to change this into a donut-loving fortune teller. I can change the text in the 2 send scrolling text blocks to a fortune, like, you will win a lifetime supply of donuts, or you will become a donut. Now when I press the button, instead of seeing yes or no, I can see one of the 2 donut fortunes that I wrote. What do you think of that, Monty? Monty?
Hey everyone, $1 fortunes and maybe donuts. I didn't really understand that part.